In this video, we'll be talking about lines and linear equations. Example 1 says you decide to join a gym that offers a membership plan with a startup fee of $25, then $22 per month. Part A says how much will you have spent on your gym membership in total after 7 months? Well, I know that $22 per month is my monthly cost, and then I have a one-time startup fee of $25. So to answer part A, I would take the $22, multiply this by the 7 months, and then add on my initiation fee, and this will come out to $179. So that's the answer for part A. Part B says, how would you figure out how much you spent after any number of months? This is where a linear model or a linear equation will come in handy. So for part B, I know that the slope-intercept form for a linear equation is y equals mx plus b. And let's define our variables. Our slope is 22, and then our b value is 25. And if we define our variables, x represents the number of months, and y represents the total cost after x months of your gym membership. So this is the final answer for part B. That is the equation or model we could use to figure out how much you spent in total after any number of months. Part C says graph this model on the provided grid and label your axes. All right, so I've gone ahead and I've added titles and tick mark labels to our grid. And now I'd like to graph my line. I know that if I spend 0 months at the gym, I still have to pay that initiation fee of $25. So I'm going to plot an ordered pair at 0, 25. And then one thing we could do is we could plot for 7. I know at 7, we determined it was 179. So 175 would be here. So it'd be a little bit more than that. So I'd place it about here. And I can create a line by connecting those two ordered pairs that I've plotted. And so my graph would look something like that. We cannot plug in negative numbers for x, so this is an endpoint, but I can keep going after 10 months, which is why I put an arrow at the other end of my line. So that concludes example 1. In that previous example, we used one of the forms of a linear equation. That's this first one here, and this is called slope-intercept form. And two other ones that we might be familiar with are point-slope form, and then this last one, ax plus by equals c. This we will call standard form. And we use these for various things. The slope-intercept form is helpful in terms of graphing. The point slope is helpful if we are given a point on the line and the slope, and then standard form we will often use for systems of linear equations. Now, in the previous example, the slope was positive. Come up with a real-world example modeled by a linear equation that has a negative slope. What are the slope and the y-intercept? So there's a lot of different things we could come up with together. Let's say you buy a prepaid Visa gift card and you put $100 on it, and then every single day after that you spend $5 on some kind of dessert or snack. And so in this case, we would come up with our input variable x. We could say x is equal to the number of days that pass. And then y, we could say represents the amount of money left on the gift card after X number of days. And so if I were to create an equation for this, we would have y equals negative 5x plus $100. We have our linear equation here. Our slope is negative since the amount of money on the card is decreasing. I'll just do a quick sketch over here. This would be my y-axis, this would be my x-axis. I'd start here at 0, 100, and it would go down, and it would look something like that. So that has a negative slope. And specifically answering this question, what are the slope and the y-intercept for this example that I just made up, the slope would equal negative 5, and the y-intercept, I'm going to abbreviate this, is an ordered pair, and that is 0, 100. So that is an example, a real-world example where the slope is negative. So let's talk about slope in a more formal way. The slope m of a non-vertical line that passes through the points A and B is m equals rise over run, which is also the same thing as y2 minus y1 over x2 minus x1. Two lines are parallel if and only if they have the same slope. Two lines are perpendicular if and only if their slopes are negative reciprocals. So here are some visualizations. I have my xy plane here, I have this blue line, and I like to think about this like a roller coaster, and we read from left to right. So on this first graph, if I start down here and I'm moving from left to right, we can see that the path that this roller coaster is following is going upwards. Therefore, it has a positive slope. Then in this example, if I'm following the roller coaster from left to right, it's going downwards, so it must have a negative slope. If the roller coaster is following a flat path, then it has a slope of 0. And then lastly, if I have a vertical line, there's no slope, or we say the slope is undefined. Example 2 says find the equations of the 5 graphed lines in slope-intercept form. So let's look at line A first. I know that slope-intercept form is y equals mx plus b, and I need two components in order to construct the equation of a line like this. I need the slope and I need the y-intercept. So let's look at line A here. The way that we figure out the slope is identify two ordered pairs on our line. And I like to pick ones that are easy that go through grid lines. So there's one here and there's another one here. And in order to get from one ordered pair to another, I go up 1 unit and then over 1, 2, 3, 4 units, which tells me that my slope is m equals 1 over 4. Now recall that slope is basically a measure of how steep or shallow something is, and so as I'm constructing my line, we have y equals 1/4 x, and going back, I have identified the y-intercept. That is where our line crosses the y-axis, so that crossing or that intersection happens here, and this ordered pair is 0, -4, which tells me that my b value is -4. So there's the equation for line A. Let's move on to line B. So we have line B here. This is a vertical line, and so its slope is undefined, but here's something that often helps me when I am coming up with the equation of a vertical line. I forgot to put in the y-intercept here. This was 0, -4 for line A. Okay, so now we're on line B. I'm going to make an XY table so that I can enter in some ordered pairs that fall on that line. So here's my origin. The origin is the ordered pair 0, 0. And in order to get to one of the points on my line B, I go over 1, 2, 3, 4, 5 units. So one of the ordered pairs that falls on that line is 5, 0. this is actually negative 5, comma 0, since we're moving to the left of the origin. And then we have another ordered pair I can identify as negative 5, comma 1, and negative 5, maybe 1, 2, 3, 4, 5. So the pattern in this xy table is that all of the x values are the same. So I have here the equation of my line is x equals negative 5. So whenever you have a vertical line, the equation of a vertical line is x equals and then some number. Let's move on to part C now. I have this line here. This is a horizontal line and its slope is 0. So if I go back to this equation of my line, if m is equal to 0, so in other words, if I had y equals 0 times x plus b, then 0 times x is just 0, and so we get y equals 0 plus b, which is just equal to b. So it turns out that the equation of a horizontal line is just y equals whatever the b value is. And in this case, the y-intercept is 0, 2. And so the equation for my horizontal line is y equals 2. So this is a horizontal line. And then when I have x equals a number, that would represent a vertical line. All right, let's move on to part D. This one has a negative slope, so I'm going to have y equals some negative number. And let's see, I'm going to pick maybe this ordered pair right here and this ordered pair right here. So to get from one to the other, reading from left to right, I go down 2 units and then right 1 unit. So in that case, my slope is negative 2 over 1, which is just also can be simplified to be negative 2, and then x. And if I identify my y-intercept, that's at 0, 1. So then the b value would be positive 1. There's my equation for part D. And then lastly, I need an equation for part E. Okay, so we are on part E now, and I'd like to find the slope. So here's one grid line that my line goes through. Here's another one. And to get from one point to the other, reading from left to right, I go up 1, 2, 3 units, and then right 1 unit. So in that case, my slope is equal to the rise over the run, and I rose 3 units, and then I moved over 1 unit. And if I simplify that fraction, that's just equal to 3. So now what I can do is I can say y is equal to, it's a positive slope, so it's going to be y equals 3x plus. Now, E is kind of unique in that the other linear examples, we were able to see what the y-intercept was. However, for this line, it doesn't extend so that it touches the y-axis, or in other words, when it does touch the y-axis, I cannot see visually where it's crossing the y-axis. So in this case, we need to use algebra to figure it out. Here's how we will do that. So for right now, I'm going to say that this is some value b. I don't know what it is. However, if I made an xy table for that particular line, one of the points that I've identified is the ordered pair. This is negative 4, and this is 1. So negative 4, 1 is an ordered pair on my line. I can actually take that and plug it into the equation so that I can solve for b algebraically. So in this equation, I'm going to replace y with 1, and I'm going to replace x with negative 4, and then I have plus b. 1 is equal to 3 times negative 4 is negative 12. And then if I'm isolating b, I would add 12 to both sides, and I get b is equal to 13. All right, so here are the final answers for example 2. Example 3 says consider the linear equation 4x plus 5y is equal to 10. Example 3 says consider the linear equation 4x plus 5y is equal to 10. Part A says find the intercepts of the line, and part B says find the slope of the line. First, I just want to point out that this line is in standard form, so it's not quite as easy to extract the slope, but we can worry about that part later. In order to find the intercepts, so the x-intercept of a line, that's where the line crosses the x-axis, and so it's going to have some coordinate in the x spot, and then it would have a y coordinate of 0. And then for the y-intercept, there's going to be 0 in the x coordinate and then some numerical value in the y coordinate. So the way that I can figure out what those intercepts are is by, for the x-intercept, this is the y coordinate, so I can go ahead and inside of y plug in 0 and then solve for the unknown value. So let's go ahead and do that. I have 4x plus 5 times 0 is equal to 10. 5 times 0 is just 0, so then I get 4x is equal to 10. And then if I isolate x by dividing both sides by 4, we get x is equal to 10 over 4, and that fraction will reduce to 5 over 2. So coming back here now, my x-intercept is 5 over 2 comma 0. And then for my y-intercept, I am going to do something similarly, except now I'm going to replace the x-coordinate with 0. And if I do that, then we get 4 times 0 plus 5y equals 10. This will become 0, and then I get 5y equals 10. So 5 times some number is equal to 10. If I divide 10 by 5, that gives me y equals 2. So coming back over to my y-intercept, this is going to be 0, 2. And those are my intercepts and my answers for part A. Let's go ahead and find the slope now. There are several ways that you could do this. One way is by putting this in slope-intercept form, and the way that you do that is by isolating the y value in the equation. Okay, so I have 4x plus 5y is equal to 10. The first step I can do in isolating y is subtract 4x from both sides. Then we get 5y is equal to negative 4x plus 10. Then I can divide both sides by 5, and I get y equals negative 4 over 5x plus 10 divided by 5 is 2. So that is my equation in slope-intercept form. And I can extract the slope, which is the value here in front of x. So my slope is equal to negative 4 over 5. And there's the answer for part B. Example 4 says create the equation of a line in any form that meets the given criteria. In part A, we're given the slope of a line is negative 3 over 7, and its x-intercept is negative 2, 0. I need to use these two pieces of information to construct a line. And notice that it says we can give the equation of the line in any form. So for part A, what I would recommend is using point-slope form, which is most helpful when you have a point on the line and the slope of the line. Now, because this point here is not the y-intercept, it's not as easy to use y equals mx plus b. For point-slope form, we would use y minus y1 equals m times x minus x1. And I can replace x1 and y1 with the coordinates that I have. So here we can think about this as x1 and this as y1. So I have y minus 0 is equal to m. Our slope in this case is negative 3 over 7. And then x1 is negative 2. And when I subtract off negative 2, that changes into plus 2. And when I do y minus 0, that's really just y. So if I wanted to simplify that, I could write it as y equals negative 3 over 7 times the quantity x plus 2. And I could just leave it like that. Or I could change it into slope-intercept form if I wanted to. The way that I would do that is by distributing the negative 3/7. So just for fun, let's do that. So this is for part A still. And if I wanted to convert it into slope-intercept form, I would do that by distributing this negative 3/7 into both of those, and that would give me y equals negative 3 over 7x, and negative 3 over 7 times 2 would give me minus 6 over 7. So that would be the answer if we gave our answer in slope-intercept form. I'm going to go ahead and erase that just so we have space for part B and C. In part B, we're looking for the equation of a line that goes through 6, 4 and negative 9, negative 1. I'm going to start off by computing the slope because I only currently have 2 ordered pairs that the line goes through. What I can do is I can call this x1, this y1, this x2, and this y2. And if I use the slope formula, then I can compute the slope. So I have negative 1 minus 4 over negative 9 minus 6. And this will be negative 5 divided by negative 15, which simplifies to be positive 1/3. And how do I know that it's going to be positive? Well, if I do a very quick sketch of these 2 ordered pairs, let's say 6, 4 is right here, and then let's move that back a little bit, maybe negative 9 and negative 1, that would be about here. If I connected those with a line, we can see that the slope has to be positive because this roller coaster, as I read from left to right, is going up. So let's go ahead and clean this up a bit. For part B, we found that our slope was 1/3. And once again, I can use point slope form for part B. I have either of these ordered pairs now that I can use. Maybe I'll use this one, x1, y1. So I have y minus y1, which this case is 4, is equal to 1/3 times x minus x1, which is 6 in this case. So here is an answer in point slope form. And again, if we wanted to, we could change that into slope-intercept form. All right, part C says we're looking for a line that goes to the point negative 3, 2 and is perpendicular to y equals negative 1/2 x plus 7. Remember from previously we said that 2 lines are perpendicular if their slopes are opposite reciprocals. The way here, this slope is negative 1/2. The way that I find the opposite reciprocal is by changing the sign, so going from negative to positive, and then taking the reciprocal, which means you swap the numerator and the denominator. So its opposite reciprocal would be positive 2 over 1, which is just the same thing as 2. So I need a line that goes through this ordered pair and has a slope of 2. Once again, I'm going to use point slope form. So I have y minus 2, which is this 2 is this 2 right here, is equal to this 2, let me use a different color. This 2 right here is this 2, it's the slope, and then times x minus negative 3, which is the same thing as plus 3, and this is coming from this thing right here. It's a lot of highlighting. Okay, so this is my final answer for part C. And again, suppose I wanted to convert that into slope-intercept form. The way that you could do that is by isolating y. So if I add 2 to both sides, I would have 2 times x plus 3 plus 2, and I could distribute the 2 and then combine like terms. So I get y equals 2x plus 8. So that's an alternative if you wanted to present your answer in slope-intercept form. Example 5 says solve the linear equation for the unknown variable. I'd like to isolate y in this first equation in part A. I will do that by distributing negative 1/2 into both of these terms, and that will give me negative 5 times y plus 1 plus 3 is equal to 14. I'm going to combine like terms. My next step is I will subtract 4 from both sides. And then finally, I would divide both sides by -2. And so my solution here is y equals -2. If I wanted to present that in set notation, I could also say just the number 2 inside of a set of curly brackets. So that's also an option. In part B, we have the equation -2 times the quantity 2x minus 7 minus the quantity x plus 3 is equal to 6 times the quantity x minus 1. In this case, I need to do a lot of distribution. So if I do some distribution, I will have -4x plus 14. I need to do more distribution here. Minus x minus 3 is equal to, and then the last distribution I would have equals 6x minus 6. And from here, I'd like to combine like terms. So here I have -4x minus x. That's going to be minus 5x. And then I have positive 14 minus 3. That's going to be, let's see, plus 11. And then on the other side, I don't have any like terms, so I'll leave it as 6x minus 6. From here, I'd like to isolate x, so I'm going to add 5x to both sides. And I'm also in this same step going to add 6 to both sides. 6x plus 5x is 11x, and then 11 plus 6 is 17. My last step, I will divide both sides by 11. And I get x equals 17 over 11, or if we put this in set notation, we have this. Thanks for watching this video.